Very good afternoon to one and all present over here. Good afternoon, Dr. Suraj Sharma sir, speaker for today's session number 7. He's from Triple IT Bhubaneswar, and the topic for his session is deep learning through ANN using Python. Welcome, Suraj sir. My voice is audible, sir? Am I audible?
Yes. You're
Yes.
audible, ma'am.
Yes, sir. Thank you, sir. So you can share your PPT now.
Right. Okay. So, uh, good morning to all of you. This is Dr. Suraj Sharma from Triple IT Bhubaneswar. Uh, I am going to take a talk or a lecture in this particular training program related to deep learning through ANN using Python. Now, before going to the actual version of ANN, let's talk about nowadays why many people are talking about deep learning and why it is more popular in today's world. So there are many reasons why the deep learning concept has been popping up in today's world, and why it is used in different areas of AI. So the first and foremost reason is the data growth. Like every company, if you see today, they have their website, they have their mobile applications, and these website and mobile applications are used to generate different transactional data, and lots of transactional data are generated by these sites and application, as well as if you see the social media. uh, we used to put our videos, our photos, and many other multimedia content, as well as we do comment, right? We write blogs. So it is generating a lots of data, and these data are actually the fuel for the neural network for its training and learning. So that's why the in today's world, the data is available in a huge amount. uh, then only we That's why we thought of deep learning as a concept, and we are working on it. So in today's scenario, we can do with the social media content like Twitters, we can do some sort of Twitter sentiment analysis and all, right? So that was not popular, or that was not possible before, where data was not data the huge data was not there, the volume of the data was not there, right? Now, the second reason here for the deep learning, I must say that it is the hardware advancement. Let's say if we'll talk about the previous days, let's say my graduation days, where my computer was so much resource constraint. It has, let's say, hardly 512 MB of memory, right? And with these hardware, I cannot even do some sort of neural network C++ programming, and it is a very hard task to run or to work on the AI examples, right, or AI practical. But as the advances of hardware was there, and right now we have a good amount of resources available in our desktop as well as in our laptops, right? More or less, we have some other advancement in hardware in the form of CPU, then we have the advancement of GPU, then we have advancement of TPU, that is transfer flow processing unit, and all these processing unit are very good for the deep learning, where we can do some sort of parallel processing, and it is very much popular. So previously, when it is taking a lot of time to get the result, in today's in the hardware advancement, it is a fraction of second we are getting the result, or the model has will be trained. So that is one thing. That's why the deep learning has advances in today's world. Next, very popular reason why it is uh, why the deep learning has come up is the open source ecosystem like Python, right? So even if you don't have to be the computer science graduate to write the Python program, or you doesn't have to be the software engineer to write the Python program, right? Or there are different open sources ecosystem that has been made. uh, so any person who has some mathematical background, they know about the statisticals of the data, they can learn the Python in and hardly in 1 week, and they can do the deep learning programming, right? And it is very easy in today's scenario. The next one I must say is the advancement of cloud. So even if you doesn't have that much of the GPU unit or TPU unit with you, you can rent a machine into the cloud, and you can work over there, and you can do your programming there. And it is very easy to work with these cloud service providers. They can create your virtual machine in a fraction of second, use them for, and most of them are free, right? So use for your research purpose, use for any other purposes, and it is very handy to have these resources with you. So the resources is not an issue in today's world. And next thing is AI boom, right? And in this technological world, every company, every firm is having the AI enabled some sort of problems, and these problem will be solved by the AI experts, and the machine learning and AI experts are in demand in today's marketplace, right? As well as with the help of these, we can help the companies to grow their businesses, to increase their revenues, to decrease their what we can say, the wastage, right? So what I found is these are the main reason why the deep learning is so much popular in today's world. Now, for deep learning, we generally have some neural network techniques. What we can say, neural network ways to do the deep learning is, we have ANN, that is artificial neural network. We have CNN, convolutional neural network, and we have, let's say, RNN, that is recurrent neural network. So there are many ways of how we can do the deep learning in today's world. So in this particular lecture, I am going to focus here at artificial neural network, and I'll let you know about this particularly, and slowly we'll try to see what is the limitation, so that we have moved on to convolutional, or in some application we move on to recurrent neural network. So let's talk about the artificial neural network, the basics of it. Many of you have the prior knowledge about it, so that's good, that is very good. And if you doesn't have any, so I'll start from very basics so that you can understand it. And after that we do some sort of programming also, hands-on sessions related to the Python programming, and we'll try to understand the insight of it. And let's hope that you all will enjoy this particular session. So in the artificial neural network, we talk about a neuron, right? And this particular neuron is, or the artificial neural network, that is the hypothesis that the mental activity consists primarily of electrochemical activity in network of brain cells called neurons. So we equivalent or we try to what we can say, mimic the brain, how the brain works, and in the form of programming we try to mimic it. So in the artificial neural network, the neural or the neuron is look like this. uh, it is inspired by this hypothesis. Some of the earlier IT work aimed to create artificial neural network. Other name for the field including, these are the other names of the artificial neural network that has been proposed, but ANN was the popular one that we are learning, and we are doing research in the basis of that particular name. Now it looked like a neuron, and here if you'll see in the diagram, we have different inputs, and these inputs are coming from different sort of sensors. Okay, and these sensors has different weights, or sensor data has different weights, so weight has been given in the form of bias. Then we have this input function which will do the summation of all the input that we are getting. After that we have an activation function which the output of this activation function will tell, like, the input what is given to the neuron is going to be activated or not. So for that we have an activation function, and then we are getting the output. So output is in the form of is in the form of, like, is an active or it is not active, in that way. And then we have these output links which will be again going to different neurons, or it might be given to different parts of the brain where other works will go on. So let's say if we'll take an example of a human body, right? So let's say in a human body we have different type of sensors, right? So we have, like, eye, we have ear, we have tongue, right? We have skins. So all those are different sensors which are sensing our environmental data. So you just see that with these sensors, brain will get these inputs. Okay, brain will get these inputs, and based on the input and what input has what weightage, based on that, activation function has been applied and the output will be generated. And based on the output, the actuator of our body is working. So here we have the sensors which are generating the data and giving it to the brain, and from the brain the signal will go to the actuators, and these actuators are used to give the movement of our body. So if I'll take an example of, let's say if I want to see that how much my, let's say I want to press my cloth, and I switched on my iron machine, and this iron machine is heated or not, so that I can do the press to my cloth. So what I'll do is I'll just put my palm into the iron machine and just see that how much hot it is, right? So if it is not that much of hot, so that signal will go to the brain, and brain will say that how much uh, heat my hand can bear, right? And if it is hot, so it will just tell the actuator, it means my hands, to take off the hand from the iron, right? So these much of processing is done by the brain, and in the artificial neural network we try to mimic the same thing in terms of programming. Okay, and use these for the machine, so that the machine can also think like a human being. So that is the idea behind this neural network. So with one neuron, if we are making a machine that is called perceptron, where we have these inputs will be given to the one neuron, and this one neuron will make the output for us. So definitely we have some weightage depend upon from where my input is. So in the previous example, the full weightage has been given to my skin sensors, which are sensing the heat of the iron, right? So the full weightage will be given to that. In that way, weightage will be there. It will just compare it with the human being, and then inside that, the input has been aggregated, and the function activation function has been applied, and based on that the output has been created. Okay, so as you can see, the this particular input function is calculated like this. So we have, this is the input, x1, x2 and x3, and there is a weight on each input, and based on that we do the summation. And this particular is the, what we can say is the normalization function that will apply there. So let's take an example and try to understand how this neural network works. So this is the data. This is the data where we have the age, and this showing the age of different persons. And here is the 0 and 1. This shows that a person has taken the insurance, or the person has not taken the insurance. Okay, so this is a binary classification problem where the age is has been given to the function, and we have to come up with a function that can predict if the person will buy the insurance or not. Okay, so with this particular data, so next time if we'll give some sort of age, and based on the previous data, my neural network will predict whether the person will buy the insurance or person will not buy the insurance. Okay, so it is a binary classification problem. Now, if we'll see the example of this, and we'll try to draw in the form of a graph. So we have a scattered graph like this, where these points are taken by the age, and these points are for 0 and 1. If it is 0 means they are not buying the insurance. If it is 1 means they are buying the insurance based on the ages. So this is the input what we are getting here based on this particular data. Okay. Now, what we do is we apply the linear regression on it. So you all know that the linear regression, for that we have a equation like that y equal to m into x plus b, right? So where m is the coefficient and b is some bias factor, or you can say intercept, and x is what is the input. So here x is nothing but my age. So when you apply that, with the linear regression, a line has been drawn, and this line will be like this. And when we do the 50% of it, so it will give me the value somewhere like this. Let's say 42 is the age of the person, and beyond 42 they are buying the insurance. Okay, so beyond 42 they are buying the insurance, and less than 42 they are not buying the insurance, right? So there is some value that we are getting. So if the age is, let's say, more than 42, they are buying the, and there are some outliers also. You can see some of the nodes which is outliers. So in machine learning, we have some values. We are not getting the 100% accuracy, right? So we'll get some because of the training data, we are getting some outliers data. And with that, we can conclude like more than 42 age of the people are buying the insurance. So that is very fine. But let's say if I'll increase the data size, and if I'll say like around 82-year of lady is also buying the insurance. So one data will come here. If one data is coming here, my if I'll apply the linear regression, my line will be like this. So if that particular data has been inserted. So previously what I am getting 42 as the age, threshold age, but right now I am getting around 48 as the threshold age. And it is saying like more than 40, more than 48 is coming, then only it will be, it is buying the insurance. So it is just like my value, if my value is beyond 0.5, it means it is they are buying the insurance. If my value is less than 0.5, means they are not buying the insurance. And here there is a issue of misclassification of data. So there is some problem of these data. There is some misclassification that I can do. And this is again the outliers data that will be there. So how to solve this particular misclassification? That generally happen when we apply in the linear regression approach. So let's go for the other approach that is called logistic regression. Now here the activation function that has been applied, here it work with the sigmoid function, which is also called logit function. This particular sigmoid function will give me, if I apply in that particular line, if I apply the sigmoid function, it will give me that particular curve. And this curve is pretty much good for my work, because if you'll see that it is coming in that particular way and the outliers has been reduced. This is the outliers. As I told you, in machine learning, we have these values. Now, if you'll see the data, this is 38 around. So if the age is 38 and more, they are tend to buy the insurance, right? And if it is less, they are not at all buying the insurance. So this particular function is giving me somehow good prediction for my problem. So that is nothing but my sigmoid function. If you see the sigmoid function, the function will be represented like this. Sigmoid z will be equal to 1 upon 1 plus e to the power of minus z. So if z is the input, we'll apply the z here, and based on this, it will give. So e is nothing but a Euler's number, which is nothing but the constant value, just like your pi value, and we have many constant and unknowns, right? So Euler's is also a sort of constant. The value is 2.7128, and there are many other digits are there. Now, if we'll apply like this in the sigmoid function some positive value, so this value will become near to very small, which is near to almost almost 0 and it will be 1. So 1 divided by 1, you are generally closing to 1. You are getting the value around 1. And if you are getting some negative value, you are getting the value which is almost close to 0. So this sigmoid function, whatever input you give, it will convert the output in the range of 0 to 1. Okay, it will give the value in between the range of 0 to 1. So this is the best suited function for the binary classification problems, and that is your sigmoid function, right? Now, if you'll see what has happened is in the linear regression, this particular function is the first step on that, and when we apply this particular value here, when the sigmoid function, we are getting the value z, and z is my prediction, right? My prediction whether the person is going to buy the insurance or not. So the input is the age, and my predicted value is z it is giving. So if I'll give the input, I'm getting the z. If I'm giving the age, I am getting whether they are going to buy the insurance or not, right? So this whole process that we have seen till now is you just keep in mind that we are learning here the neural network. What is neural network? And that learning of the neural network is the process that we are following here. Okay, so just keep in mind to that, and let's go to the programming, and we'll try to mimic what we have learned till now, and with this particular sigmoid. So we use this particular sigmoid function is nothing but it is based on the logistic regression. So we'll apply the logistic regression in our input data, and we'll try to understand that what we are getting as a prediction if we'll provide the age. Okay, so I hope this is visible to all of you. Like, this is the Jupyter notebook, and here we do some sort of programming. So first, what we do is we see how this logistic regression will work. So for that, we import some libraries. So the first library that we'll import is the pandas library, and for the graphs and all, we'll use matplotlib. In that we have the pyplot. So these two library we first import here, and the second thing what we do is we try to get the data. So we'll get the data with the pandas, that is pd.read csv. So we have the insurance data with us. This insurance data in the form of csv file, right? And let's see the insurance data, and we'll see the some let's say 5 insurance data we have. Let's say if you want to see the whole data, you can see also, right? So this is the data that we have, which I have shown you already into the PPT, right? So this is the data. So we have seen the scattered graph of that particular data, right? So we can do it with this age, and whether the person will bought the insurance or not. So based on that, we'll just make a graph. So the graph will look like this. Okay, now on this particular graph, if I'll draw the line like this, it will your linear regression, right? Now Now the next thing that we'll do is we'll use the sklearn library. In that, we first do the splitting of our data. So my data is this, right, that we have imported in df data frame. Now what we do is we split the data and we'll try to put the data into the training variable and the test variable. So what we have done here is we have taken the training size as zero point 0.8, means 80% of the data we have taken for the training. In that way, we have split the data into two parts. So as you can see, the test data, what we have is this. This is my test data. And the train data, if you want to see, so these are my train data, right? This is my training data. Now let's import the sklearn from the sklearn library. Let's import the logistic regression function. So in the logistic regression function, we have put it into the model, and then what we do is we train our model with the logistic regression. So the model dot fit. Now we are going to train our model. After training the model, we just, if you have seen, we have this test data, right? So this is my test data here. This is my test data. You'll see. Yeah. So this is the test data. Now we'll apply this the model which we have already trained. We'll apply this test data on this particular model, and we predict the value, the y value. Okay, so the y predict will be the model dot predict, and we'll apply this test data here. Now let's see the y predict here. So we are getting an array of, this is the test data. So as you can see, the prediction is like, if the age is 62, the prediction is 1. If the age is 28, the prediction is 0. It means that if a person's age is 62, he is likely to buy the insurance. If the person's age is 28, is not going to buy the insurance based on uh, our model, right? And if you can say 52, it is they are going to buy the insurance. 50, they are going to buy the insurance. 60, yes, they are going to buy the insurance here. Now let's see the prediction probability here with the test data. So is this for this particular 62, it is coming around 86 score, 86%. It means that it is more than 0.5, means it is 1, right? 28, second one is coming 0.48. It means that it is less than 0.5. So that's why it is coming 0. Then for 52, as you can see here, it is coming 78, and for 50 also it is coming 76, and for 27 it is coming less than 0.5, it is 0.75, and for 60, age of 60, it is coming around 0.83, means 84% of the probability that they are going to buy the insurance. Okay, now let's see how our model are scoring based on the test data. So the score is around 83% of the model. The model is giving us around 83%, right? And so in the uh, linear regression, the coefficient, the m value that we can calculate with model dot cuf underscore. In that way, it will give me the coefficient value that we are getting, as well as the intercept value also they can provide us, that is b, right? So that value also we can get, that is coming like this. So this is how we can do the logistic regression. And if you want to do the programming related to the logistic regression, that also we can perform here with the help of the the sigmoid function, right? So that also we can do. For that, we'll import the math, and we have a sigmoid function. The sigmoid function will be like this: 1 upon 1 plus this exponential of minus x, that x is nothing but my age. Okay. And here, if you'll see what value we are getting here is it is around, this is for m value that we are getting, and this is for the d value that we are getting. Okay. And we apply this, and right now we'll call the sigmoid function with the age. Let's say the age is somehow 35, then what is a prediction? So it says that there is a 97% of chance that he or she can buy the insurance. Okay. If my age is, let's say, or in this prediction, if I'll put my age is, let's say, 30, so let's say whether how much it is giving. It is giving 96% of the chance that he or she can buy the insurance. Right. So in that way, we are getting some values. Wait a minute, there is some. Right. Now it is coming exactly what we are thinking. Now, if your age is 30, they are near to buy the insurance. If the age is 26, they are not going to buy the insurance based on our linear regression. Sorry, sigmoid or the logistic regression classification problem. Okay. So this is nothing but a glimpse of the logistic regression. Now let's again go to the PPT. So as you can see, these value also has been created here, has been calculated, and this value has been calculated. So when I have calculated previously, the value is coming like this. So I have put it like this. Right now the value has been changed, as we have seen already into the program. So this is like, first we'll calculate this, the linear regression, and then we'll apply this y value into the sigmoid function, right? This y will be applied here, and we'll calculate the value of z. We'll calculate the value of z, and that is z is my output. Like, so we are getting the input as the age, which is x, and we are getting in the form of z as the output, like some values. So as we know that if the value is less than 0.5%, person is not going to buy the insurance. If the value is more than 5%, more than 50%, it means that they are likely to buy the insurance. So if the age is like 43, they are giving this particular value there. Okay. So this is what I am getting previously. And if I'll run right now, so in 35 also, the the person will buy the insurance. So it is the beauty of the machine learning that it will not give you all the time the same result, right? Now, what we have seen is we have seen one feature here, that is the age in this a neural network, and if you see this, this will look like a neuron there, right? This is a neuron there, and we have one input there. Now in the neuron we have different inputs like this. So for that we should have different features like this. So instead of doing the linear regression with only one, we have, let's say, the age. Second, let's say we have the income, and third, let's say the education. So based on the age of the person, based on the income of the person, and based on the education of a person, if we are going to predict like he or she will buy the insurance or not. So here we have the multi feature, and when we give this particular value, these particular value are, I have put some random values here. These are all the weights. These are all the weights. And if I'll make it a general equation like this in mathematics, so it will be like this: is a summation of 0 to n wi xi plus b. So it is look like the input function of the neuron, and this is nothing but your activation function. So this is nothing but your one neuron, right? So as I told you, we are learning neural network, and we are learning it in the form of an example. So we have different input like age, we have income, we have education as the input. We have some weightage there. Based on that, let's say the age has the highest weightage, income has the least weightage, and the education has the after that we have the weightage there, right? So we used to provide some sort of weightage. Based on that, a person can take the decision, right? And this decision will be in the form of this. Now let's see that how this neural network works in actually in the real world. Okay, so as we know, till now we know that the structure of a neuron, and what that neuron is in the neural network. Now let's see that's how this neural network is actually working, right? So let's take an example. The example is we have a set of people. Okay, we have a set of people, and these set of people are getting a task. Task is to find that animal, who that animal is. So this animal is a cute looking animal whose name is koala, and we generally find in Australia continent. So let's say the people, they haven't seen this particular animal previously, and they are asking like whether that particular animal is koala or not, right? So what they do is they will learn this particular feature of the koala, and they will tell that whether this animal is koala or not. So for that, what they do is they provide the feature of the koala to each and every person to be expertise. Let's say the Mike has given the eye feature. So Mike will be looking for the eye, and training we'll talk about later. So you just see the scenario where the eye of one feature has been given to one person, that is eye has been given to Mike, nose has been given to Mohan, legs will be given to Jyoti, and let's say the other part of the koala has been given to another person to be expertise. Now they will score based on 0 and 1. If they are thinking like the eye what Mike has given is not the eye of the koala, so they will give the 0 score. If they will think that it look like koala's eye, so they will give the value like in between 0 and 1. And if they are sure, 100% sure that this is the eye of the koala, so they will give you the score like 1. So they will give you the score in between 0 and 1. And every feature of the koala has been expertised by these persons, right? So let's say that is the expert and he has given some value based on the uh, other input what Mike has been allotted. Mohan has given the value, other input what Mohan has been allotted, and Sakib is working on the ear expert. So they are all expert right now, and they know what features they have learned. Right now, these feature input will be given to the second level of supervisor. Let's say we have the Serena. What Serena will do is they will get the score of all these features, and the Serena will use an equation like this, that I what Mike has given the score, the weightage will be like zero point 0.2, the nose the weightage will be zero point 0.5, and the ear the weightage will be zero point 0.3. So koala has a unique nose, right? So nose is unique from many animals. So that's why the weightage has been given like 50% to the nose. Eye is also prominent, but the most prominent feature is nose. So weightage has been given to it. And based on that, it will find out like it is the face of the koala or not, right? The same thing happen here, and the score they are getting is around 0.79, means it is more than like the threshold value, let's say 50-60%. So they find out like it is the face of the koala. If the face of the lion has been given and they have given the score like this, so they will find out like the last value that they are getting is below the threshold, so they are saying like this is not the face of koala. Now let's assume that these three people are working with the face and these two people are working with the lower part of the koala, and they will give their input to the next level, which is Serena and Nidhi. Serena and Nidhi will do the calculations, and the calculated value they will give to Sergey, which is the next level of calculating the whole animal value. So the 60% they will give you the face, because the face is more prominent way to describe any animals, any means to differentiate between animals. And body has given a 40% of weightage, and based on that, the Sergey will decide like this is koala, the whole picture of that is koala or not, right? So that is the process that has been applied in neural network, and this is the way how they are going to work. Now let's talk about the training, how the training will be done, and yeah, so how the training will be done. Now for the training, what they do is they use different pictures of koala, and in the picture, from the picture, they will find out the different features. So if Sakib is the ear expert, Mohan is the nose expert, and Mike should be the eye expert, so they will be given different pictures of it. And after that, they will decide at the very beginning I am talking about, because it is a training process. So at the very beginning, they have given and they have been told and to give the score. And based on the score, the Sergey will say that whether the picture that they have been given is of koala or not. If they are saying that the score is coming around 0.4%, means they are thinking like it is not a koala, and they will go to their supervisor. So there is a supervisor. This supervisor will validate the output what they are getting. if the supervisor says that, yeah, you're wrong, it is actually koala and you're getting the wrong value. So what they do is they will take that particular feedback to their next level, and this will give the feedback to their next level. So that particular process are called back propagation error. So in that way, the error has been back propagated and the weightage will be adjusted, right? So the backward error propagation what process will be done, and they will adjust the weight based on the feedback what they are getting, and in that way they will learn different pictures of the koala, and they will again go to the last supervisor and ask their feedback. In that way they will fine tune their weighting. So in that way the thing will go on and the learning will be done. So this learning is just like how you learn your bicycle, right? So you, most of you have, or I think all of you learn bicycle in your childhood. So how you have learned the bicycle, right? The balance of the bicycle is critical. So if you don't know how to how to handle the bicycle, it is very tough, right? So previously you might have fall down lot of time, right? And that is the time when you are learning. So what you are doing is whenever you are falling down means you are getting the feedback, and that feedback has been corrected in your mind, and the correction will be done in your mind, and at one point of time you will be so trained, and now you can run the bicycle, you can run the bike, right? So this whole process is the training process. The same process has been applied here in the artificial neural network, what is happening in the human brain, right? And yeah, so this is your artificial neural network. And somehow if you are learning the bicycle in your childhood, so what you are doing is you are doing deep learning, right? You're doing actually the deep learning, and here you can see you have one input layer, then you have one hidden layer, and then you have one output layer. So these are the multi-layer perceptron, and multi-level perceptron is called your artificial neural network, where we have different layers in that. So this is how the weight will be adjusted, the equation for it, how the weight will be adjusted. So as depend upon the input, and the output will be generated, and output will be compared with actual output, and the error will be given to again the input, and this will be, the weight will be adjusted. So the whole process is done with forward propagation and backward error propagation method. In that way the weight will be adjusted all the time, and your machine will be fine-tuned based on that. So this is the example of supervised learning, right? So as we have many features like the age of the person, the education of the person, the income of the person, the saving of the person. Based on that, if we are predicting that whether a person is going to buy the insurance or not, so it will be done like this. So let's say the age and education is defining their awareness, the person's awareness, and the income and the saving is defining the person's affordability related to the insurance. Okay, and in actual neural network, it will be densely given the input to all the neurons. So each neuron is giving the input to each input will be given to each and every neuron. So in that way, the actual learning will be done. So now what we do is we work on the ANN or the neural network, first we make a neural network model with the help of with the help of only one layer, where we have the input layer and output layer. And after that, we'll add on the hidden layer and we'll see what is the difference. So are you getting it? So first of all, what we are going to do is we are going to find out, or we are going to run a model where we have the input with only one layer. So input and output layer is there, and then we are putting the hidden layer also in it, and we'll try to understand that what is the difference when we add an hidden layer on it. Okay, and what is the difference in these activation function. So there are many actually activation function. Let me tell you that first. So this is nothing but the activation function. Here you can say this is your one hidden layer, if I'll assume that, and this is your the output layer. So generally for this output layer, we generally use the sigmoid function. Okay, so the sigmoid function will look like this. Okay, where we have the value like this. And for the hidden layer, we have some popular activation function. So some of the popular activation function is, it is 10H. It is the curve of the NH is look like a sigmoid, but the Y value will go from +1 to -1. Okay. And there is another function which is called activation function, which is called RULU. Okay. So for that, this diagram is like this. So in that way, what we can understand is it will go up to 1, right? So what we can understand is whatever input will give, if the input is the negative input, it will convert it to 0. If input is the positive input, so that input is coming as a output. So that X value, whatever the X value is, if it is less than 0, so the output will be 0. If the X value is greater than 0, then the output is X only, right? So this is the RULO, and it will be generally used in the hidden layer. This is the popular choice for the hidden layer activation function. Then we have a function called step function, right? And we have a leaky ReLU also. Leaky ReLU activation function, and if we draw the diagram, it will be like this. So if your value is negative, still it is giving some value here, which is in the form of negative. And if your value is positive, it will be the same as X. Okay, so there is some modification that has been done in RULU that will find out the max of 0.1 of X or X. So whatever is maximum, it will take it as the output in the RULU, but in the leaky RULU. But in the RULU, the equation is like this. It is a max of either 0 or X, whether it is giving the value 0 or it is giving the value X, whatever is the maximum. Okay. So these are all related to the activation function. So I want you to know about it because we are going to use it in our program. And in this particular program, we are going to do deep learning on the handwritten character recognition. Okay. So we have these sample handwritten digits, and these handwritten digits are from 0 to 9, and we are going to train our model so that it will learn the handwritten values 0 to 9 and try to give as the predicted value if I'll give some sort of input to it. Okay. So this is just like your character recognition. Here we are doing digit recognition. Now, here we have a number of input, and you can see in the neuron we are getting the output in the form of 0 to 9. Now, this particular this image is as this is a grade level image, it will go from 0 to 255. The white portion is 255, other portion are 0, and there is some gray portion which are having some value in between 0 to 255. So if I'll draw in the form of the pixel value, so it look like this. So here you can see the value is highest. Here you can see some lower value is there because of this. Here some value is there. Here some value is there. Here some value is there. Other values are 0 because here there is no white part. Where we have some white part, the values are given, right? Now, what we do is, so generally we have this pixel in the form of 2D array, and this 2D array, because the neural network, we have to give the input in the form of a linear array, or you can say the one dimension array. So we'll convert this 2D to one dimension. That process is called flatten. So we do the flatten the input, and we give the input, and we are getting the output as 0 to 9 only, right? So we have 10 outputs. Output is 10, and we have the input. Let's say for this particular example, it is 7 by 7. It will be 48 inputs. 49 inputs. But in our actual program, it is the grid size of 288 into 28 into 28. So my the input size is 728. So I'll convert this 2D array to 1D form, and this I'll do like this. So I'll read row by row, and I'll put it here in that row by row. I'll read it. So that is the flatten process that we have applied. And if somebody is if the input, let's say this is 2, so the output is like this. So the output is showing like 2 is having the highest percentage. Other character has written some values, but 2 is having the highest percentage. It means that my output is giving like this. So the output, if it is giving like this for the index 2, means that this particular character is 2. Right? So it will be, the output will be like this. So let's do the programming and try to understand that. Okay. So let's say in this particular file, we will write the program for just a glimpse of deep learning through ANN, artificial neural network, with no hidden layer, and then we'll add one hidden layer and try to understand what is the difference between these two. Okay. So for that, let's have the TensorFlow. So TensorFlow is a library that we have to install before doing this particular program. You can do without TensorFlow also. And the TensorFlow library has been installed. This TensorFlow is from the Google. You can use also PyTorch, which is a library from the Facebook. And we have used the Matplotlib and the NumPy for other way. And this from the TensorFlow, we have used the Keras library. Okay. Now after that, what we do is we get the input, the character handwritten digit data from the Keras library, Keras dataset only. So we use Keras dataset dot mnist dot load dot data. So we load it into two form. One is in the training, another is at rest. So this data is in that particular form where we are using train data and test data there. So let's find out the length of the training data. So for the training data, here has been used around 6,000 sample. So sorry, this is 60,000 sample has been used for the training, and let's do for the testing. So for the test, how much data has been used? Here it has been used 10,000 for testing. So total and written character data is around 7,000. The division has been done in that particular way. Okay. Now, if you want to see what is there in what is the shape of one particular the data, so the shape of one data is one training data is this, which is 28 into 28, as I told you in the diagram also. So in the diagram, as you know that the shape of one character is 28 into 28. Okay. Now, uh, if you want to see that particular data, let's see that data as this. So this is there in the first digit, the data, which is as you can see, there is some value like 253, 250, 78, 23, right? So these data are there. I think it is clear that why these values are coming. Now, if you want to see what is there in the data, we can just draw with the help of the plot. So as you can see, this is the 5. It looked like 5, okay? So if you want to know the index of it, so just go on that Y train, and this is a X train. First number of character, this is look like 5. What index is what? It is a supervised learning, right? So with the character, there is another value which is called Y, and it is telling like this is 5. Okay, so it is 5. So it is clearly a handwritten digit. Now, what we do is we have just seen the training data, right? Train data and this data, and let's say what is the shape of whole training data. So the shape is how much is 6,000 comma 28 comma 28. It means that we have sorry 60,000. We have 60,000 sample of 28 into 28 shape, right? And the test is 10,000 into 28 into 28, right? So I doesn't have to look for the test also. Now let's see. What we do is next thing that we do is we flatten the data. Okay, so we flatten the data means these are the in the 2 dimension. We'll make it into 1 dimension because we have to give that particular input to the neural network. So we have to flatten it. So the training data, it is there in the X train flatten, and the test data is there in the X train flatten. So in that way, we have flattened the data. Now the shape has been changed, right? So previously it was 60,000 of 28 into 28. Right now, if you'll see the same thing with the flattened data, the shape will be 60,000 into how many? The data size is of 1 dimension, and this is the dimension size. It is 28 into 28. It will be 784, which is our input, right? This is our input to the neural network. Now, after flatten the value, let's let's make a model, and with that particular model we'll make the we'll draw all the input layer, output layer, what how much we required, and what is the activation function that we'll use. So all will be here. So we have used the Keras sequential function there in the Keras layer. The layer we have used the dense layer, means every input will be given to every neuron, right? So the output that we are looking for is the shape of 10, means 0 to 9 is my output layer. Then we have the input we have 784. The activation function here we have applied is the sigmoid activation function. Optimizer is Adam. Then we have the loss, that is sparse categorical cross entropy. This is the loss in the different loss uh, in the Keras library we have. If you want to see what that particular loss is, we have different type of losses. Here we have categorical cross entropy function. Loss is here. If you want to see what is there inside, you can see. Just a minute. Here we have sparse categorical cross entropy class, right? So this is my, so the definition of the sparse categorical cross entropy loss is here. You can go through it. That we have used here. Now let's run it, and after that we do the start the training. So model.fit train X to train Y, and how many epoch we have used is 5. So 5 number of time the whole process will go on. So as you can see, the training is right on in place. Okay. So as you can see, you are getting some accuracy. In the first epoch is 84. Second epoch it is coming more like 87. So epoch means at one training, then in the back propagation again the training will be then again back propagation. So this thing will be go on, and you are getting the accuracy around around how much? 88%. So I think the accuracy is quite less. Okay, so we forgot one thing, which is the scale down or scale this particular input. So the input is like this, right? We'll scale it to 0 to 1 value. So for that, what we do is we just after this we can after this what we can do is we can make, and it will be divided by 255, right? So we can do the training and testing data will be divided by 255. So for that we'll start from the very beginning. So we'll start from here again. So yeah, we have flattened the value, and this value is 253. Let's see what that value will be right now. So as you can see here, yeah, so it has been scaled. So right now the value is from 0 to 1, right? So it has been scaled. Now what we do is just do the whole process and we train it again. So previously it is coming around 84, 88%. Let's see whether the accuracy has been, yeah. So it has been increased, right? It is coming around 91. Let's see that after 5 o'clock, how much accuracy we are getting. So this is the process in on the ANN. We can, based on the input. So what input we are taking, have we done the scaling of that particular input? So based on that, your accuracy will also change, right? So that thing you have to keep in mind while doing this machine learning and all. Okay, so let's do. After that, let's evaluate the model. So the model evaluation is how much it is coming. It is also coming around 92%, 92.5%, right? So this is the accuracy that you are getting from the test set model. Let's say in your first test value, what is the value that is 7, right? So whether my model is able to predict 7 or not, right? So for that, let's again flatten the value and just find it out. The predicted value of the 0th level is what? So 0th level it is giving. So as you can see, it is coming around 99.9%. It might be for the 7. This is for 8 and this is for 9. So let's make it easy and with the help of argmax, let's find out the maximum in this particular input. So here the maximum is 7. So as your output is coming as 7, right? So the predicted output is 7 here. If you want to see in the level, the first 5, the values, that is, okay, why predicted level? It is not defined. So let's make a list comprehension to flatten or find the maximum argument in the predicted value, and then we'll apply this. So yeah, so this is the predicted value. So the first value that they have predicted is 7, second value they have predicted as 2, then 1, then 0, and then 4, in that way. Now let's draw a confusion matrix out of it, so that we can get to know that how much loss we are having in this particular model. So CM stand for confusion matrix. Let's say we are printing CM. Yeah, this is the confusion matrix that we have. Let's draw it in a very colorful way, so that we'll try to understand. The same thing is there. We're just making it in a more colorful truth table. Now here you will see with that what you are getting is if you see this particular value, like is coming 46. This is the predicted value and the actual value, which is the same, right? So in the diagonal, it is giving me that particular accuracy of how much is the predicted and how much is the truth. Now if you see this particular value like 46, so it is saying that 46 time a machine is predicting wrongly 8. 46 time an image has been predicted 8, which is actually 2, right? So the 46 time this machine is predicting a value to 8, which is actually 9, which is actually 2. So it is wrong prediction. So here these values here are nothing but your error that you are getting in this particular model, right? So now what we do is we just make another hidden layer, and we train our model with that particular hidden layer, and we'll try to see how it is working. So for that, the code is the same. Here we have added one more hidden layer. In the hidden layer, that we have taken as 100 layers, because the input shape is 784. So we have to take the hidden layer less than that. This is the output layer. The activation function that we have used in the output layer is sigmoid, and the activation function that we have used in the hidden layer, that is ReLU. So I told you about the ReLU, and it is very popular to use that particular activation function in hidden layer. Rest of the thing will be the same. So here also the 5 epoch has been used. Let's see if we are getting the better accuracy or not. So previously the accuracy was 92, around 92.5 is the accuracy that we are getting without the hidden layer. And let's see with the hidden layer how much accuracy we are getting. So we are getting the accuracy more than that. So here it is around 92, 96, 97. So we are getting the more accuracy. Here it is taking time. Why? Because we have increased the computation by adding the hidden layer. And this particular hidden layer has the 100 neuron we have taken, right? So that's why it is taking some time. So right now accuracy has been increased. As you can see, it is coming around 98%. So previously without the hidden layer, it is coming around 92%, right? So now what we do this, we do the same thing. We first make the level of it. Okay. First we can evaluate that how much is the accuracy with the test data. So we have just done the training. Now we'll do, yeah, here we just evaluate the value here. So it is coming around 97% accuracy, and it is good than 92%. Now the second thing that we'll do is we just find out the maximum from that particular argument. After that, let's draw the confusion matrix. Is my CM, okay, confusion matrix. Let's draw in that particular form. Yeah. Wait a minute. It is the same that we are getting. Okay. It is taking the Y prediction. Yeah. Okay. Let's do the evaluation. 97% is okay. Let's do the flattening it. Confusion matrix. Now it should change. Yeah. So I think it has been changed. Now let's see this. This has also been changed. So as you can see, in this particular confusion matrix, we are getting around 46 time. The model was predicted 8 as, sorry, 2 as 8, right? 2 as 8, because actually it is 2 and it has predicted 8. This is a prediction. Now in this particular, after the hidden layer has been added, as you can see, now from 46 it has been reduced to 12. So 12 term is still a model is predicting 2 as 8, 2 as 8, right? So here we are getting the error, but error is less than what we are getting into the with the help of this without the hidden layer part, right? So this is one example of the deep learning through ANN, and here we have done the digit recognition, and we are getting, or we have just replicated this. This is without the hidden layer. One hidden layer we have used here, and this is the predicted value that we are getting. Okay. So now let's go to our okay, let's go to our PPT. So I hope you understood some of the features of ANN, and what is the significance of those activation function, and this is a glimpse of deep learning. So see, deep learning in today's world, we can have many examples. So from the image classification to object detection in video processing, so all those are called actually computer vision, right? So in that we use generally CNN, that is convolutional neural network, and that is an example of deep learning. And there are some limitation of ANN. Because of that, we move on to CNN. As you can see, these are some of the example of computer vision, which is the deep learning technique we can use in medical images, we can use in document understanding, aerial inspection. Then we have precision manufacturing, content management, product discovery, damage assessment, agriculture crop pest analysis, environmental conversion, then warehouse automation, content moderation, geology analysis. I'll let you know some of the example, like some of the example that I have seen and I have faced. Like you all know the Google lenses, right? That is there in the Android. So with the help of Google Lens, you can find it out that which type of image that is. So let's say if I don't know about the trees, right? So I just take the picture of the tree and they will tell me that which type of tree it is, right? Or which type of which this particular leaf belongs to which particular tree. This is very good example of computer vision. Next is, in today's world, when you want to uh, get the money from the check, so what you do is you go to the bank and deposit the check. Now instead what we can do is we have the mobile application and the internet banking. We just go and just click the check and we upload it, and they will get the feature of the check, and they will find out the authenticity of the check, the deep learning technique, and they will clear it. So that process will be more faster. Now, if we talk about the agriculture and all, we can do some crop counting. Sorry, this let's say the apple counting, and we can find out the yield, how much we got. Autonomous car is also a great example of computer vision and deep learning technique, where the different camera has been used in autonomous car, and they can actually do the automatic right parking, or you can call your car where you are, they can come. So that is practically they have already implemented in Tesla and all, right? Then there is one example like retail store. It is the vision of Amazon Go store, and that Go store is already there in US. In that store, there is no person. You just should have your Google app uh, on at that particular time, and just have a QR scanning and that particular Google app. You just enter in the QR in the shop, the Go shop, and while you are going out from the shop, it will just scan what are the item that you have used, and they will put all those item in your cart, and from the Google Pay, the money will be detected. So with the help of that, we can do many things, the deep learning, right, in today's world. Uh, so that is one part of the deep learning, that is through neural network, artificial neural network. Then for the computer vision, for precise computer vision, we use convolutional neural network, that is CNN, where one part is the convolutional, another part is the neural network, right, that we have learned just now. Then we have RNN, that is also used for different applications of the computer vision. And that's all related to the introductory of deep learning through ANN and Python. So thank you very much. If you have any doubt, I'll be happy to clear your doubt.
Thank you so much, Dr. Suraj sir. Participants, if you have any doubt or query, you can ask. Any doubt from participant side?
Dilkeshwar Pandey.
Yeah, Dilkeshwar Pandey sir has raised hand for his doubt. Okay. Okay. Yes, sir, you can ask the question.
Mute your mic.
And please unmute your mic and you can ask. Anybody else who want to unmute?
कर दिया
Sir, he is asking what is 10
What
in
is?
what is 10? Indents 10. He is asking for indents 10.
I didn't understand. Could you clearly ask
Uh,
that what is the question?
Sir, please check the check box, chat box.
Okay.
Hello, sir.
Yes.
So it was
Okay,
nice
dance
speaking.
10. Okay, okay. So dance, let me answer this first. This in this particular program that we have seen, in that we try to make the neural network to be trained, right? So for that we have used this. In that we have used keras.layer.dense. So we have used the dense layer phenomena, where the 10 stand for the output layer. So as in the diagram you have seen, we are getting the digit value from 0 to 9, right? So it means that 10 output we should get. So 10 stand for that, and dense is not alone. Dense it with keras.layer.dense function that we have used. So in the dense function, what will happen is every neuron will give the input to the next level of neuron, or every input will be given to every other neurons. So that is the meaning of dense. I hope it is clear.
Okay. Mr. Suraj is also asking questions, sir.
So, Pawan,
Yeah.
Yes, sir. Please
s-
go ahead.
Yes, sir. I want to ask about the activation functions that we have used, like ReLU, LiKeReLU, and 10H function. Then, if there are many multi layers, then can we use different activation functions, and what will the result of these activation functions?
Yes. So as I told you briefly about different activation function, like for different type of, let's say the binary classification problem, we use generally the the sigmoid function as the activation function. As you can use 10H also, you can use Rulu also, but the popular activation function for the hidden layer are Rulu or 10H that we generally use, and for the output layer we generally use the sigmoid function. So it is not like that. See, machine learning is all about learning, right? So you also have to learn that how much accuracy you are getting if you are using this activation function, how much accuracy you are getting if you are using another activation function. So it is all hit and trial method that you have to apply to get your model more accurately trained.
Sir, so it means the accuracy will depend upon the input and the weighted function and the activation function and many factors, no, sir?
Yes. So depend upon the input, you have to see what type of activation function will be best suited.
Thank you, sir.
Okay, thank you. So Pandey sir was asking like it should be hidden layer. Sir, there is not like if we have the hidden layer only, then we have to make a dense, right? The input layer, from the input layer, how we are providing the input to the next layer means next, let's say the neuron. So how the input will go to the neuron, it is also the thing, right? So it is the input to the neuron is dense we have applied there. It means that each and every input will go to each and every neuron. Yes, sir. So 10 output layer is there because of our need. Our need is to find out the values for 0 to 9. What is the value that we are getting for 0 to 9? So for that we have used 10 output layers.
Sir, deep neural network is generally used for graphical images, or we can use for it integers or other data type also.
Yes, so we have different yeah, for generally the deep neural network is used for those image recognition, as I told you, many applications. So on those different application, we use uh, deep neural network or deep learning model. We have CNN, we have RNN, as I told you, ANN. So there are some limitation of ANN. That's why we went to CNN model, which is more complex. The convolution will be done first, and then those output of the convolution we use to put into the next level, which is the artificial neural network.
Suganya, madam.
Sir, Suganya ma'am is asking that is in wireless sensor network how deep learning is useful
Checking
See,
question.
in chat box.
deep learning is deep learning is don't be confused with the wireless sensor network. The wireless sensor network is having different applications. It has the applications of IoT also. We can use this wireless sensor network into the IoT infrastructure. So wireless sensor network is nothing but a network of sensor which is generating the data, and these data we use to send to the gateway node, and this from the gateway node the data will go to the cloud, and from the cloud it will go to the user. Now whatever data it is generating, if you want to do some sort of analysis on that, then the deep learning will come into the picture. So these sensor network are generating the data. If you want to do some analysis on those data, then you can use the deep learning technique. But otherwise, the wireless sensor network research is completely different. So it is, the deep learning is only about the data. The data sources could be wireless sensor network, it could be IoT, it could be social network, right? It could be the medical imaging, it could be the pictures, it could be the video. So the input, data input could be from any sources.
Okay, thank you, sir. I
Okay.
hope Suganya ma'am has got her answer. One more question, sir.
Good afternoon, Dr. Suraj sir.
Good afternoon, sir.
Okay. So one of my doubt is there that if we build a model and train it and test it in deep neural network, and if I want to migrate the whole model from one system to another system, is there any process in that?
One system to another system, physical
Yeah,
system you are talking about?
that physical system. If I want to
No,
migrate
no,
from my local system to any
there,
other system or in the cloud.
yeah, there is no issue on that. There is no issue on that, but you have to train the model again into the migrated system. Means you have
But
written the
the
code and
drawback is
all.
that if we increase the hidden layer, the timing is very much to train the model, and that same timing is also being done in other systems also.
Yes,
Is
so that,
any system is not there that we can train and test in our system and just deploy it in the cloud and other systems?
so actually we use the cloud if we doesn't have that much of computing resources, right? So we use the cloud and we'll take the help of the cloud service provider to give us some good GPU so that we can train our system and get the result. Ultimately, if you are doing this particular work as a product, or you are doing the work as a research. So if you are doing the work as a research, if you are migrating your code to one system to another system, so when you are migrating to the code to another system, you have to again train your model.
Okay. Thank you, sir.
Yeah, Pandey sir, you are saying that there is one output layer with 10 neuron. Yes, you are correct, there is only one output layer with number of neuron as 10, but what I am saying is there are 10 outputs because we have 10 neuron, so that's where we are getting 10 outputs. Okay, so I think the model is shown there in the form of the diagram, as well as the same diagram I have implemented in the Python. So I think there should be no confusion.
Okay, thank you so much, sir. Thank you, participants. Dr. Suraj sir, I hope you will share your PPT with us.
Yeah, sure, I'll share that.
Okay. Thank you. Thank you, sir. Thank you so much for joining us.
Thank
Uh,
you.
for participant, The feedback link and the quiz link is open. Please give your feedback and quiz also. And from here, we have a lunch break. After that, at 2:30 p.m., we will join for another session. So please give your feedback and quiz. Thank you so much.